for today is 8255 or BPI, the Programmable Peripheral Interface, which is interface to the microprocessor. Now 8255 is the IC number and comes in a DIP, which is a dual inline package. So dual inline package means there are two lines of 20 pins each. Okay. 20 pins each. Okay. So what does this mean? That we've got 40 pins. Okay, so we've got 40 pins. That's the total number of pins we have. And out of that we use 24, so we use 24 pins for ports, that is input and output. Ports. So since you probably know that we've got input ports, so we've got three ports: ports A, port B and port C. So port A and B are of 8 bits each. Now port C is divided into C upper and C lower, which are both of 4 bits each. Now this is actually the block diagram of a PPI. So let's start with this. This is actually the read-write control logic, or as you can see, the brain of the PPI. The brain of PPI means it actually gets the signals from the microprocessor through these lines, and then it further sends the commands. So this is a read signal, this is a write signal, this is chip select signal. So all these signals with a bubble in front of them means that they are active low, which means that they're only active when the signal turns low. Supposedly this is a read signal, so the read signal would turn active when the signal goes low from 1 to 0. Okay, and here it again turns to inactive state. This is how, so the this is how this works. So this is read signal, this is the write signal, and this is CS or the chip select. So when the chip select is 0, then only the PPI will work. These are A0 and A1 and the reset signals. So we'll talk about this very soon. This is the data bus buffer, which holds the data from D0 to D7. This is a bidirectional data bus, as you can see. So the D0 to D7, which actually come from the microprocessor. This is the 8-bit internal data bus of the PPI. These are the two control parts, the group A control and the group B control, which further control group A port A and group A port C upper, group B port C lower, and group B port B. So actually group A and group B control group B, port B fully and port A fully. Also they control partly port C and partly port C upper and port C lower. Okay, so let's talk about what are the control signals. Now control signals depend on A0 and A1. So if we want to select port A, we need to write something. We'll go for A as in A0 and A1 as 0 0, then you go as A01 10 and 11. My mistake, I think I'm wrong. Yeah, this is the correct part. It's A0 and A1. It only starts from the right to the left. I would like to apologize for it also. So if you go for port B, 01, port C, and this is CR or the control register. So every time you need to write something here, this part, you'll put the port address as 11, right? Now let's talk about modes. Now PPI has got 3 modes, which we say that it's 3 modes, but it's actually 3 modes in IO. There's one more mode which is known as the BSR mode. Let's talk about first the IO modes or the input output modes. Okay, the input output modes are, we change the color, mode 0, which is the basic input output mode. The basic IO mode, or the basic IO mode, is actually the mode in which we do not have any handshakes. We have no handshakes. Try to remember these parts, because these things will actually become the properties when you'll be explaining the modes. Okay, so no inputs and outputs. Okay, we'll come to these parts, that what mode A and mode 0 and mode 1 do. So we need to be very correct about writing out these. So yes, so coming out, this is input ports are not latched. output ports are latched. Okay, so input ports are not latched, but the output ports are latched. Okay, and there is no handshaking. This is mode 0. Okay, let's draw how mode 0 looks like. This is the A, this is the CL, this is the CU. Oh, I'm sorry, this is the CU. I'll draw them again. This is the CU, this is the CL, and this is B. So all of these work as IO. So all of them work as basic input output modes. Let's talk about mode 2. Oh, sorry. Yeah, mode 1. So mode 1 is also called the strobed IO mode. Here we get handshaking. Remember, here handshaking and control will be used interchangeably. Okay, here both are latched. So remember, outputs are latched always. Inputs are only not latched in mode 0. Rest always latched. Both. Okay. So let's talk about the diagram. Yeah, this is A again. This is CU, CL, and B. So here, no difference here. So let's draw the 4 bits. So what happens is these 3 bits and these 3 bits are used for handshaking. Or as I like to say, control. To generate control signals with the IO. Okay, and these two, they're used as IO input. So you need to remember this, that mode 1 is a strobed input output mode which uses handshaking. Let's come to the next part, which is mode 2. Mode 2, exactly the same part, which is strobed bidirectional input output. Node changes here. You've got A, you've got B, you've got CL, and you've got CU. Now here A actually turns to bidirectional bus. So it's a bidirectional bus. This means that it becomes a dictator kind of thing. It can be input or output as it wills, okay, or as it is needed. B remains the same as input and output, one at a time. Let's talk about the pins here. So here, 5 of these pins are used for handshaking again. Yeah. And these 3 pins are used as IO, input output. Okay. So now let's come to the next part, which is the port A, mode 1 output. So you've got here you've got PC3 to PC7 working for us. So what had happened is we've got an interrupt A, an OBF, an acknowledge, and an input output. These two will work as an input output lines. Okay, this is a signal generated by the microprocessor. So cool. This is an AND gate. Yeah, this is an AND gate. Okay, this is the interrupt signal. Okay, which will be sent to the microprocessor. This is OBF. Okay, I'll be explaining this below. So the OBF is an active low output which tells that the output buffer is full, and this is the acknowledge. Okay, so this acknowledge actually is by the peripheral. But wait, we'll come to this very soon. Now, so these are a few terms you need to keep in mind and you need to explain it when you are drawing the diagrams. So obvious is an active low output. So wherever you see the bar, you know that it's an active low output. So it means that the output buffer is full. So we know that outputs are always latched. Okay, I'll write it here again. Outputs are always WICS latched. Only inputs in mode 0 are not latched. So the output buffer is full. Acknowledge signal is given. If this is an example of a peripheral. If peripheral, yeah. So if my peripheral gets the sends me an acknowledge signal. Okay, this is the interrupt enable. Okay, this is by the microprocessor that the microprocessor has been interrupted. So now what needs to be done? Okay, so so these are the output control signals. Now coming to the input control signals, let's change the colors. So these are the IP control signals. So this has got the strobed input. Okay, so not properly. Yeah, so it's the strobed input. It says that the input buffer has been loaded into the. So it means in short form, input buffer full. Clearly, INT is again interrupt enable. So let's have a quick recap. What all needs to be done, and change the colors too. Wow. So first of all, if you get a question to write about the PPI or Programmable Peripheral Interface 8255, what you need to do is give the IC number. It is 821S55, right? Tell that it is a dual in 9 package. Explain about the total number of pins used for port. There are also pins D0 to D7 which are there, which gives 8 more pins. So you get 32 pins, and the only pins you need to remember left are which are exactly precisely here. Got 1, 2, 3, 4, 5, 6 more pins you've got here. Okay, and you're left with 8 pins. 2 pins are left, so like I'll total them here. So you've got 6 pins here. From this you get 6 pins, 24 for ports, 8 for data bus, and 2 are PCC and ground. So you've got total comes to be 40. So you got 40 pins. Okay, so you need to remember this. Draw the block diagram, explain each part properly, explain the modes. Explain what A0 and A1 does. They are the control signals. Okay, then explain what modes are there, the input out mode and the BSR mode. Then explain the modes properly and define what handshaking means. Draw the diagrams. Right, explain each part of the diagram properly, because as I said in the previous videos, the diagram will give a particular insight, a graphic insight of your mind to the teacher. The teacher is always acts as a layman when he is checking or evaluating your notebooks. So please try to be very specific about the answer which you're writing. And some things which need to be explained also are A0, A1, explain them. Okay, and what is VCC and ground? Since this is a different chip and which is not working, like taking power from the microprocessor, it is individual chip. Also explain what does CS bar, RD bar, WR bar and reset is. That's it, and this will explain everything. Also D0 to D7, which is actually which is actually a bidirectional data bus from the microprocessor. That's it. Thank you so much.